demo I wanted to show real quickly here is to give you an idea of what one of our sensing technologies can actually do to give my laptop here a sense of what the user is actually doing. So what I've got inside this box here on the table is it's a 3-axis accelerometer. So an accelerometer is a sensor in your car right now where if you stop quickly and hit somebody, we measure that large deceleration and deploy the airbag system. It's also in the Nintendo Wii controller or the iPhone, where it's basically just measuring gravity. Am I this way or this way, so I know which way to turn the pictures. This sensor is about 1,000 times more sensitive than that. And I'm going to show you kind of what that application space gets us into. So what's going up on the screen up in the upper right-hand corner is red, green, and white lines, which correspond to the 3 axes of the sensor. If I tap on the table, we see spikes as I put one in there. I'm actually going to bump the table in this direction, and you can see it oscillate as I move the table. This is actually a pretty solid table. So, back and forth. What I'm going to do with these signals, though, is if I take the acceleration, meters per second squared, I can integrate to velocity, which is the middle plot here in meters. And I can double integrate to the bottom one, which is actually position. It comes out in meters. So if I just take my box and I move it this direction, what you see in the signal on the white on the bottom is that we've actually gone from 0 up to between 0.05 and 0.055. This is in meters. So I just moved 53 millimeters across my table here. So if I take it and actually push back, I can find my way back to 0. What I'm actually doing is the sensitivity of this sensor is allowing me to navigate along the desk and figure out where I'm moving on the desk. So this same technology is what you want to be able to move through a building when you lose that GPS signal and to find your way to a room inside the building. The red one moves as I go left and right, and you may notice that as I move this way, the red one moves a little bit because I can never go exactly straight. I'm always kind of picking up a little bit on one axis or the other. So if I take that signal and through a little bit of programming, I can hook it up to the mouse pointer on the screen, and now as I move the box on the table, you can see the mouse pointer going back and forth and up and down. So now I'm translating this navigation into an interface that's very important. Now the last part I want to show you here is around the computer. That's an input device. You're familiar with that. I can do the same thing with this. No rocket science there. What we want to show is that if I've got this in on the table, I'm working on the table, I'm typing away on my laptop, I get upset and frustrated with the equipment, I hit the table, and still everything looks normal. As soon as I pick this box up, the interface changes. Okay? And I change the mouse cursor to show that paradigm shift from the XY, which is the mouse pointer, to if I was giving this as a presentation, I've now got a laser spot on the screen. And as I tip and tilt this box, I can move that spot around on the screen and show you what I'm doing. The important thing is that as soon as I set this box back down on the table, it switches back to the other system. So it knows now I'm no longer holding it, it's back on the table. We use this as a security device inside the laptop now. I now can tell the user has picked it up. So if it looks on my schedule calendar and it says I don't have a meeting within 15 minutes from right now, perhaps I'm out of the office, if somebody comes in and picks up my laptop, I hopped over to the other application, so let me just click in the background there. Normal. Sorry. Picking back up, back in this mode. So if I get picked up and I get moved, it's likely that I'm being stolen. You give me 10 seconds to put in a password, and if you don't do that, I encrypt the hard drive, lock up the hardware, and you can't touch the system. So set it back down on the table, we know we're down. So I've only met one person that could actually fool the system while holding this up here and that it's actually stationed right down there. So it's an awareness of the computer. This is the first part of building a smart thing. Sustainability, it's a screensaver that knows what the user is doing based on the vibrations. So if I'm talking to a slide, as long as somebody's in the room, somebody's making these signals that you can see on the table, that somebody is around and vibrating, we know we don't need to put the screensaver on, even if I've talked way longer than my 10 minutes on my one slide. So